Hi, here we go again. Today we're going to be talking about rectangles, rhombi, and squares. So, rectangles, you probably recognize this shape right here. Rhombus looks really similar to a parallelogram. It actually just has a couple special properties, and I'm sure you know what a square is. So you can see that all three of these shapes are all four-sided, which makes them all quadrilaterals. Remember, a four-sided shape is a quadrilateral. So a rectangle, a rhombus, and a square. Not only do they have four sides, but the angles, the sum of the interior angles will be 360, no matter which one of these quadrilaterals it is. A rectangle, a rhombus, and a square, they're also all parallelograms, which means opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, the diagonals bisect each other, so they'll cut each other in half. Just to keep my picture kind of clean, I'm not going to draw that in there. And then what's that last one we're missing? Oh yeah, consecutive interior angles are supplementary. So besides all those parallelogram properties, rectangles have two properties that set it apart from a parallelogram. So what makes it not quite a parallelogram, just a little bit more special. So the definition, you probably know just from looking at the picture, is that all angles are right angles. So every single one of those is going to be a right angle. So that is the definition of a parallelogram. I'm sorry, the definition of a rectangle. It's a parallelogram with all right angles. So that's what defines it. That's what sets it apart. Now there is a bonus property, and because these are all right angles, the sides aren't leaning away from each other. Now they're straight up and down. It takes those diagonals that bisect each other already, and because we're going straight up and down, it actually means the diagonals are congruent. So in a parallelogram, because it's slanted over, we've got two corners that are pushed further away from each other, creating a long diagonal, and two corners that are pushed closer to each other, creating a short diagonal. So in a normal parallelogram, the diagonals are not congruent. But in a rectangle, because we aren't pushing one of the corners closer to the other one, oh, that wasn't straight, the diagonals actually will be congruent. So if they are congruent and they're bisecting each other, let's say this whole thing was 10, then if it's bisected, this would be 5 and this would be 5. But if the diagonals are congruent, then this is 10, which means this is 5 and this is 5. So if everything's 5, doesn't that mean all the pieces are congruent? All right, so let's move on to a rhombus. Now, a rhombus looks a lot like a parallelogram. So it actually is a parallelogram, which means it has all of the parallelogram properties. Opposite sides parallel, opposite sides congruent, opposite angles are congruent, diagonals bisect each other, and consecutive interior angles are supplementary. But there's a couple special things about a rhombus that set it apart. So what makes a rhombus a rhombus? The definition is that all sides are congruent. It has four congruent sides. So it's a parallelogram that has four congruent sides. All right, there's a couple other special things that happen with a rhombus. So the diagonals are not congruent. They are not congruent in a rhombus because, again, we've got two corners that are pushed closer, two corners that are pushed further away. However, the diagonals do bisect each other because it's a parallelogram, and they form a right angle. Now this is only true in a rhombus, not in a parallelogram. The diagonals are perpendicular. That means they form right angles. All right, besides the diagonals forming right angles, they actually do something really special to this entire angle here. It cuts it in half. So this whole angle and this whole angle, they're already congruent because it's a parallelogram, right? So the opposite angles are already congruent. But what the diagonal in a rhombus does, it actually cuts this angle exactly in half. So all of these little pieces, all those little parts of angles will be congruent. Same thing in our other one. This whole angle is already congruent to that whole angle, but the diagonal cuts it in half, which means those will all be congruent too. So the diagonals bisect opposite angles. That means they cut the opposite angles completely in half. All of those halves will be congruent to each other. All right, the last one is our square. So you probably could recognize a square really quickly. When somebody says a square, what's the first thing you think of? Is it that all four sides are congruent? Or is it that it has four right angles? Or is it a combination of both? Well, a square does have four congruent sides and four congruent angles, which means if it has four congruent sides, it's a rhombus. And if it has four congruent angles, it's a rectangle, which means a square has all the properties of a parallelogram plus all the properties of a rhombus because of the four congruent sides and all the properties of a rectangle because of the four congruent angles. So a square is kind of like the child of the rectangle and the rhombus. It gets all the parallelogram properties from its grandpa, all of the rectangle properties from its mom, all the rhombus properties from its dad. So it has all of them, a ton of properties for a square. So I'm going to give us a family tree to fill out tomorrow, and then that'll be a really convenient place for you to have all of the properties. So we'll work on that tomorrow. Right now, we're just going to try to work off these lists here. All right, so let's put some of this into play here with doing some examples. So example 1, find the requested angle measures and defend your answer. So defend your answer just means tell me how you know. So if you can figure out how big it is, we're going to work on explaining to somebody, convincing somebody that, oh yeah, I know this and this is how I know. Because I'm sure you hate it when your mom's like, do this, and you're like, why? And she's like, because I said so. Like, we want to have a definitive defense, a convincing argument. So that's what we're going to work on. All right, so here's what we know. We have this quadrilateral. I can see that it has four sides. Do you notice these two sides are parallel and these four sides are congruent? So we already know it's a parallelogram because if you remember from the other day, one of our tests is if we have a set of sides that are both parallel and congruent, it means it's a parallelogram. Well, this parallelogram has four congruent sides, which means, you got it, it's a rhombus. All right, so if this is a rhombus, then it's going to have all of the parallelogram properties from the other day, plus these three bonus properties. All right, so let's see if we can figure some of these angle measurements out. So we know that DAR, this whole thing, is 124 degrees. So we're going to see what we can figure out here. All right, so we don't have to go in order. We can go in any order we want. We can actually figure some stuff out first and then put it in our picture. It doesn't matter. We're just going to think our way through this. So the first angle it asks us for is DAY. So DAY is actually part of the big angle DAR. It's actually the right side of that. And if you remember, one of the properties we wrote down is the diagonal bisects opposite angles. So that means this diagonal, AT, is cutting DAR in half. So if DAR is 124, then that means how big is DAY? Well, that would make it 62 degrees. Awesome. All right, so how do we know that? So we know that because the property, the diagonal bisects the opposite angles. Diagonals bisect opposite angles. Now you can put that into your own words. That's totally fine, but here's the nice part. We're really just using one of our properties to back up what our answer is. So if you can't think of a good way to write it, most likely just copy the property and that will get you to where you need to be. All right, next one is AYD. So A to Y to D. That's this angle right in here. All right, so how do we know how big that is? Well, if we look at our properties, remember it's a rhombus, just look at your rhombus properties. This angle, AYD, is actually formed by our two diagonals. And right here it says our diagonals are perpendicular, which means they form right angles. So that would tell us AYD is 90 degrees. How do we know that? Yeah, just write down what we have up here. The diagonals are perpendicular. Or you could write the diagonals make right angles. The diagonals form right angles. Feel free to put it in your own words. All right, so the other day I told you I'm a mathematician. I like to use symbols. In case you don't remember, this symbol right here means perpendicular. I don't like to write the word perpendicular. It has too many letters. I like to use a symbol. So it looks like an upside down capital T. Okay, next angle, YDA, YDA. All right, so this one's gonna be a little trickier because we don't have any information. We do see that YDA is half of this whole big angle. So remembering that the diagonals bisect opposite angles, it's literally gonna be half. So if we can find the whole big angle, we can just divide by 2. Can we come up with anything? So a couple things we could do here. First of all, we've already found that DAY, this angle right here, is 62 degrees. And the diagonal, do you see the diagonal is actually creating a triangle right here? DAY is a triangle. Well, we also just found this to be 90. So couldn't we just do triangle sum theorem, which says there's 180 degrees in a triangle? So if I know this one is 90 and that's 62, could we find that angle? All right, so we are going to do, I'm going to use, at least on this one, the triangle sum theorem. It just says 180 minus 62 minus 90 is going to give me my angle. So that will give us 28 degrees. So this angle right here, we are doing 180 minus 90 minus 62 as part of triangle DAY. All right, last angle here, ART. So ART, that's this entire thing. What are we gonna do? So we know this angle right now is how big? 28. Which means if the diagonals are bisecting the angles, this angle is also 28, right? Because a rhombus is a parallelogram, that means it has all the parallelogram properties. So this entire angle here is equal to that entire angle there. So ART is equal to ADT. So if we do 28 plus 28 to get 56, then this angle will be equal to that angle. So ART will equal 56 degrees. All right, what are we gonna write in this blank? What did we just do? So one thing that you could say is that opposite angles are congruent. Opposite angles are congruent. So we know that angle ADT is equal to angle ART. It's just that simple. You don't have to write a ton. You just have to let some people know how you were thinking about your problem. Okay, let's look at our next example. Okay, so we are going to find the requested angles and defend our answer. Okay, so we know we have another quadrilateral and we have 4 congruent sides. So we know for sure it's a rhombus because of the 4 congruent sides. And then we need to know if this is a square. So how can we tell if this is a square? Well, it definitely looks like a square, but we never want to assume that a shape has a right angle in it, or all the sides are congruent, or all the angles are congruent. We need to be told that information. So right now, the only thing we can do is say this is a rhombus. Now, it definitely looks like a square, and it was supposed to be a square. I forgot to put the mark in it. So I'm going to go ahead and mark that in there. I'm going to put a right angle mark in angle S there. All right, so if this has 4 congruent sides and a right angle, that means all these angles have to be right angles, which would make it a square. Okay, so I want you to pause the video and see if you can find these 3 angle measurements and see if you can come up with something to write on those because lines. So let's start with QAR. So QAR, so if we know that this angle right here is a right angle, that means opposite angles are going to be congruent. So this angle right here is going to be a right angle. So this has to be 90 degrees. Now, you could say lots of things here because it's a square, so it has right angles. I'm just actually going to use because it's a parallelogram, opposite angles are congruent. Opposite angles are congruent in a parallelogram. QRA, QRA. Okay, so that's this angle right here. Now we already know it's a square. We know opposite angles are congruent, so we know this is going to be 90 degrees. Now if all 4 sides are congruent, it makes it a rhombus. Do you remember that the diagonals of a rhombus make a 90-degree angle here where they intersect, but they also cut these angles in half? So if this whole angle is 90, then half of that, this side right here, should be 45 degrees. All right, so 45 degrees because diagonals bisect opposite angles. All right, last one is ASQ. So that's this angle right here. So again, we know that this is a 90-degree angle. The diagonals bisect the angle because it bisects opposite angles, so we've got another 45-degree angle. Diagonals bisect opposite angles. Awesome. What else do we know about this picture because it's a square? Well, we would know the diagonals are congruent, so QR would equal SA. What else would we know? We could say, well, if we had a letter right here, if I called it X, we could say that RX is equal to XQ. We already talked about how all the angles are right angles. We know the diagonals are congruent. We've already talked about how the diagonals bisect opposite angles. We mentioned how our diagonals are going to create right angles. So lots of information we can pull from that picture because it's a square. All right, last set of problems here. So we've got a sometimes, always, never. All right, number 1, is a square a rectangle? This is always true. Why is this always true? Because a square has 4 right angles. All right, what if we go the other direction? Is a rectangle always a square? Sometimes, always, or never. This one is sometimes, because sometimes a rectangle is long like that. Sometimes a rectangle looks like that, right? So this is sometimes because a rectangle doesn't always have what makes a rectangle a little bit different from a square. Is that a square always has 4 congruent sides. So sometimes, because a rectangle doesn't always have 4 congruent sides. Sorry, my dog's barking at people walking past my house. All right, number 3, a rectangle is a rhombus. This is never true. Why is this never true? Well, because a rhombus doesn't have 4 right angles, and a rectangle doesn't have 4 congruent sides. So rectangle doesn't have 4 congruent sides, and a rhombus doesn't have 4 right angles. All right, is a rhombus a parallelogram? This is always true. And this is always true because a rhombus has 4 congruent sides, that means the opposite sides are congruent, which is what is one of the ways we can use to prove something's a parallelogram. So this is always true because opposite sides are congruent. All right, rounding here to the end. Given rectangle UTSR, RT is 6x plus 4, so that's this whole diagonal here, 6x plus 4. SU, this whole diagonal, is 7x minus 4, and ST is 10x minus 12. Find x and the length of ST. Okay, so we have 2 diagonals and we have 1 side. So if we knew something that would represent RU, then we could set those equal because opposite sides are congruent, but we don't. So we can't use that. We do know, let me get my properties back in front of me, that a rectangle has congruent diagonals. So that means in this picture, RT would be equal to SU because those are both my diagonals. Diagonals are congruent. Okay, so then if that's true, we can just plug in what we know. So we've got 6x plus 4 equals 7x minus 4. And then this guy, we're just going to hold off on him because that's a side and that's not really going to help us yet. So now we're just going to solve this. So that's going to give us subtract 4, subtract 7x, negative 1x equals negative 8. So x equals 8. All right, so we found x. Now we're going to find the length of ST. So now we're going to use this 10x minus 12. So 10 times 8 minus 12. Oh, it's 80 minus 12. 80 minus 12. So 68. So ST equals 68. Now this is representing a length, so I'm going to put units on it, but it doesn't tell us if it's inches or centimeters, so I'm just going to write UN for units. All right, that's all for today. If you have any questions, please reach out. Otherwise, have a great day.